आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanto Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics, and its applications in various natural and social sciences. We welcome Dr. Partha Sarathi Mukherjee, who is an associate professor at the Interdisciplinary Statistical Research Unit in Indian Statistical Institute, Kolkata. He talks about himself and his work.
I am Partha Sarathi Mukherjee, currently Associate Professor, Interdisciplinary Statistical Research Unit, ISI, Kolkata. Currently, I work on image comparisons and image monitoring. Basically, I apply my knowledge in statistics in these fields.
Professor explains in detail about the process of image monitoring.
So basically, if you are having images over time of certain things, let's say an example of say medical images like MRI. Suppose we are monitoring the growth of tumor of a patient. So you are taking the MRI image of the patient over time, say after 3 months or 6 months, and whether the treatment is working or the treatment is not working. So that you have to decide from the growth of the or the shrinkage of the tumor. So that's the basic idea. So basically currently what we do is that the doctors basically look at the images and then they decide whether the treatment is working or not. And then they decide the next course of action. But the thing is that this is very subjective because different doctors may look at the same image and interpret differently. That's one issue. And also in countries like India, we have a shortage of doctors and doctors are overworked. Sometimes it's not possible to spend much time on each images or on each patient. So that's why my research on the image comparisons and monitoring basically automates the process. So I'm basically developing a method where it reads the images and then they statistically compare whether there is any change or they are remaining same.
Dr. Mukherjee focuses on the application of such a new area of research.
So at this point, basically, we are developing the methods and we are basically publishing in peer-reviewed journals. Actually, we have also softwares that is uploaded on our website that people can use. That's at the very nascent stage of this development. Basically, this area is quite new and not a lot of researchers are currently working, not only in India, but also worldwide. So it's very new, but what we have done so far, we have uploaded in our website that people can use freely.
Sir shares how India is performing in this specifically new area of learning.
India is among the only few countries, maybe only few research groups that are currently working on this. Maybe some research groups in machine learning and AI may be working on it, but from a very different perspective. But as a statistician, we are basically applying our knowledge of statistics to basically compare images statistically.
How common people can benefit from this research?
So one example that I have said is on the medical diagnostic, like looking at the images and automating it. That's one application. Another application that I can say is that in the area of agriculture. For example, if we have satellite images of some area over various times, we can look at the images and then compare and monitor whether the certain crop is growing well or certain crop is not growing well in certain areas. These kind of things that we can do using these methods.
Dr. Mukherjee highlights the future directions for research.
The future is very bright. Actually, worldwide, many people are realizing that the image monitoring that's important in various fields. For example, nowadays, because of the presence of high-tech products, we have images. Images is a primary form of data nowadays. That was not like this maybe 20, 30 years ago. So nowadays in various industries, for example, in manufacturing industries, where we are manufacturing certain things and we are taking a picture of it. So we do not have to inspect the products unit by unit. We can look at a picture and then we can look at the picture and infer something. That's kind of one reason that image is a primary form of data. And the methodologies on monitoring and comparing images, so we have some methods, but these are mostly naive. We need more sophisticated methods to do that. So that's what we are doing. Example of the image comparison, that one I said that in the manufacturing industries, that's one example. For example, we are having a product and then we take a picture of those and then visually we can see whether there is any defect or not. That's one thing. And also we have some other things, for example, in case of forest science, for example. So again, we can look at the satellite pictures, whether the forest area is shrinking or it's expanding. That we can also do using the image comparison techniques. So other applications, for example, the monitoring the areas of certain geographical regions, for example, monitoring lakes. Certain lakes are shrinking, certain lakes are expanding, maybe some rivers are changing directions. So we can have satellite images nowadays, then we can monitor those images and we can detect those changes, and we can do this automatically by using technologies. We do not have to do this manually. So it can detect small changes. If we want to do it manually, then it's subjective and it's very difficult to do. It's very difficult to detect small changes. But using the technology by the automated system, it can detect the changes much earlier.
Sir talks about how this research can be applied for the development of various industries.
So actually currently, I do not think the industry are using the more sophisticated products like that we are developing. So it's, as I said, it's at the very beginning of new research area. But once it is developed, various types of industries can use it. For example, that I said, the manufacturing industries, medical diagnostics, various aspects of healthcare systems. So in healthcare, you see that the various, we use images as some kind of markers of diseases. So that was not there many years ago. So if we can use technology-driven procedures to detect anything interesting or any pattern of change, that will benefit this related industries.
We thank Professor for the valuable insights that he shared with us in this episode.